Hello, everyone. In this lesson, we're going to be talking about principles of natural selection, and in particular, we're going to look at how do principles of natural selection explain how adaptations have developed in extant or living species. There are four main principles of natural selection, and these are the four things that natural selection, in order to have it kind of work out, you need these four main ideas. Number one is overproduction. Number two is genetic variation. Number three is selection. And number four is adaptation. So if we go through these four main principles, number one, overproduction. Basically what this means is that more offspring are produced than are expected to live. So in this example, there's a whole bunch of frog eggs there. Frogs produce hundreds of thousands of eggs, and they're not expecting all of them to live. Organisms are going to eat the eggs. Organisms are going to eat the tadpoles when they hatch out of the eggs. If you've ever watched Finding Nemo and you're at the beginning of the movie, they're talking about the clownfish have a nest and there are all these eggs, and not all of the eggs actually survive. So overproduction just means more offspring are produced than are expected to live. Second part is genetic variation. There has to be differences, they're called variations, within species of organisms. Random mutations cause these variations. So with the picture here, you have the dark green frogs, you have the light green frogs. Capital G would equal dark green, lowercase g would equal the light green. And so if you have, a dominant allele, you'll end up having the dark green color. If you have two of the recessive alleles, you'll end up having the light green color. And in this case, depending on the background, will depend on which organism gets selected for. So that's the next one. So genetic variation just means you have these differences. Selection means that organisms with variations, organisms with these differences, that are better for the environment will survive. So if they survive, they can then pass these good traits on to their offspring. So the one example, if you think back about the simulation that I showed you in the last lesson, the white color for rabbits was a lot better in the Arctic environment, in the snow environment, than the brown color. So that's called selection. The environment is basically selecting, or organisms, whether it's predators, whether it's food, whether it's temperature, there's some type of selection factor dealing with the environment. And there's going to be some organisms that their variations are going to allow them to better survive in that environmental condition. The last one then, adaptation, an inherited trait that allows an population of organisms to better survive and reproduce in their environment. So if we go back to this natural selection simulator game and we look at this, we can actually go through all of the different steps of natural selection, all the different principles of natural selection based on this simulation. So for example, I'm going to add a friend, okay? Rabbits are going to have large numbers. There's going to be overproduction. So what I'm going to do right now is I'm just going to let this play out. If I let the rabbits go, there are going to be a lot of rabbits. They reproduce at a fast rate, and they have a lot of offspring. And so this is what we would consider overproduction. So eventually, if there's no factor limiting these guys, okay, and there's nothing that's going to eat them, there's no environmental condition that's going to select for them, eventually we're just going to be overpopulated, and that's where you get the bunnies have taken over the world. So this is the overproduction part. Okay, this is kind of exaggerated, but this is overproduction. Okay, I'm going to add a friend, and I'm going to switch to the Arctic environment just because this is a little bit easier. And here's what I'm going to do. I'm going to add the mutation. If it's just white rabbits, there's no variation. But now, if I add a mutation, now we have variation within a species of organism. Okay, you have white rabbits and you have brown rabbits. So there's variation. Okay, now I'm going to add a selection factor. That's number 3. The wolves are the selection factor. Okay, in this case, it is easier for the wolves to see the brown rabbits, so they're going to select the brown rabbits. They're going to eat them. So if you're a brown rabbit, you have a better chance of dying because the wolves are going to see you and they're going to eat you. That means that for the most part, those traits don't get passed on. So if we let this simulation play out, there might be 1 or 2 brown rabbits left at the very end, but for the most part, right now, all the brown rabbits are gone. Okay? And if you look, I made a mistake the first lesson. I said that white fur was dominant. White fur is actually recessive here. So once the wolves take out all of the brown furred bunnies, there's no chance of getting brown fur back in the population. This is called an adaptation. The trait that best suited the bunnies for this situation was the variation of being white. That trait was selected for. That meant that trait got passed on. Those bunnies were able to survive in this environment and reproduce. Okay, so we have overpopulation, overproduction, lots of bunnies being produced. Variation, we added the brown mutation, so we had brown rabbits versus white rabbits. Selection, the wolves could see the brown rabbits better, so they ate the brown rabbits. Adaptation means that over a period of time, you would probably have the population of rabbits in this Arctic environment become white. Now, I'm going to reset this, and here's what we're going to look at. We're going to do the same simulation. I'm going to add a friend. Okay. We have overproduction, so the rabbits are going to have more offspring than what will actually survive. So there's a lot of choice. There's a lot of organisms so that this random mutation can happen. So now we have brown rabbits. Okay, so we have overproduction. Now we have our variation. We have white rabbits and we have brown rabbits. So they're variations. Now I'm going to give a selection factor. Here come the wolves. So the wolves are selecting this time because if you look at this environment, the white rabbits stand out. So it is very obvious that as the wolves come around, they are more likely eating white rabbits than they are the brown rabbits. Okay, so in this environment, the brown rabbit variation, the brown color, or the brown fur color, is better for the bunnies. And so what you're going to notice is over a period of time, you have more brown rabbits than you do white rabbits. Now, in this case, we're still getting white rabbits because that recessive allele is still in the population. So when you go through, as long as you have a heterozygous, if you have 2 heterozygous rabbits breeding, you have a 25% chance of getting a white rabbit. But as we go through the simulation, the wolves are focusing on eating the white rabbits. So that variation will get rarer and rarer. So in this case, the brown trait's better off. So that would be the adaptation. More rabbits in this environment would be brown. So the population would start to become a population of brown rabbits. Okay. So if we go back to our part with this, so I want to just kind of go back through and review. Overproduction, more offspring are produced than expected to live. Genetic variation, there are differences within species of organisms. Selection, so the environment, there's some type of selection factor where one of the variations is going to be better than the other. An adaptation over a period of time, those better variations, those better traits are going to allow organisms to survive and reproduce, and that will change the population of organisms over time. Okay, so when you think about this first part, how do principles of natural selection explain how adaptations have developed in extant species? This is how it happens. So we have overproduction, we have genetic variation, selection, adaptation. This process of natural selection, remember, is the mechanism behind evolution, which is a change in a species of organisms over time. The theory of evolution by natural selection is the theory that Charles Darwin came up with. And we'll be talking about Charles Darwin a little bit more in another lesson. All right, I hope everything was okay and you understood everything. And if you have any questions, remember, office hours are Monday through Friday, 1 p.m. to 2 p.m. I'd love to see you. Pop in, say hi, ask questions if you have any. If you don't have any questions, at least stop in and say hi if you have a chance. I hope everyone is doing well, and I miss you guys. All right, bye-bye.